So we are going to be looking at systems of linear equations. And for our purposes for now, we're going to have two equations that have two variables in them. So the solution to a system is this point where both of these equations are true. So it's something that works in one equation and it works in the other one. And these systems that we'll see will have three types of solutions. There will either be exactly one solution, which is one point. There's no solutions, so there's no point that is in both lines or both equations. Or we might have all real solutions. And in that case, the two lines, when we graph them, just land right on top of each other. They are the exact same line. Every answer that works for one equation is going to also work for the other equation because we could turn those two equations into the same one. So here's our example. I'm going to plug in a point. Let's call this guy equation 1 and this guy equation 2. And I'm going to plug in a point for x, see what I get out for y, and we will see whether that spot is a solution or not a solution to this system. So I'm going to start with plugging in 1, and I'm going to say 2 times 1 plus 1 is 3. So if this point 1, 3 was a solution, then when I plug in 1 to equation number 2, I'm going to also get 3 as the answer. So let's plug in 1. Negative 1/2 times 1 minus 4 is negative 4.5. So these are both points on their own equations, but they're not a solution of the system because it's not the same point when I plug in x. However, I know where this solution is, so I am going to just randomly pick negative 2 to plug in to both of these equations. So when I plug in negative 2 to the top equation, I have 2 times negative 2 is negative 4, plus 1 is negative 3. I'm going to do the same thing in the second equation. I'm going to plug in negative 2. When I do that, negative 1/2 times negative 2 gives me 1. 1 minus 4 is negative 3. So these are the same point in both equations. This is a solution to the system. And since we had a point that was not a solution and a point that is a solution, that means there has to be exactly one answer. We couldn't have this and have another point where they cross again. And I'll show you why. Here is that graph. If we just took those two lines, put them on our graph, we would have these two lines, and we can see the point right here, negative 2, negative 3, where they cross. That's the only solution to this system of equations because it is the only point that these lines cross. We're in a flat plane. There is nowhere else that these lines are going to magically turn and cross each other again. We have one solution. However, you remember that we could have had one solution, we could have had no solutions, or we could have had all real solutions. So one solution we already saw. One solution is where we have two lines that cross in one place. In no solutions, these two lines never cross. There's no one point that's a solution for both of these equations. They have identical slopes. They are parallel lines. And then all real solutions. In this, you might have an equation like 2y equals 4x plus 6 and an equation like y equals 2x plus 3. That one's like hopefully obvious of how those are the same equation, but they might be more complicated than that where they don't necessarily look identical when you first sit down to them, but then when you try to graph them, they come out to being the exact same line. They lie right on top of each other. And obviously my drawing does not make them perfectly right on top of each other, but you can imagine. So all real solutions end up graphed looking like it's just one line. No solutions are parallel to each other, and in one solution, it crosses at one point.